To solve simultaneous equations, we're looking for values of k and m that satisfy both equations. It appears as though the elimination method would be the best way to solve these equations because the k and m are together on the same side of the equations. Now, to determine which letter to eliminate, we need to look at the coefficients or the numbers in front of each letter. Let's first of all start by labelling the equations 1 and 2. Now, the numbers in front of the letters can be matched up with colours or in their columns. Let's have a look first of all at the k's. The coefficients are 2 and -3, and with the m's, 5 and -2. We can't add or subtract the equations at this stage, so we need to look at changing the equations so we can do that. Let's consider first of all the k values. If we multiply the first equation by 3 and the second equation by 2, the coefficients for the k values should become easier to work with. Let's have a look at it equation by equation. If we multiply the first equation by 3, we have to do the same to every particular term in the equation. 2k becomes 6k, 5m multiplied by 3 is 15m, and 4 by 3 is 12. In the second equation, multiplying every term by 2 means that it becomes -6k, -2 times 2 makes it -4m, and 5 times 2 means the constant at the end becomes 10. You can see now that with the coefficients of the k matching as 6 and -6, it should be easy to add the equations together and eliminate the k variable. Now, that's not the only way to go. Another thing we could do, if you look at the two original equations, is multiply the first one by 2 and the second one by 5. And if you check carefully term by term, you can see the multiplication process taking place, and the coefficients in front of the m now match. So that's another way you could solve it. It's probably best that you pause here to check to see that you agree with those equations. Let's go back to our original equations and go through and solve them by adding together each equation. If we add them together, the k terms will disappear because 6 plus -6 gives us 0 for the k terms. Going down the column with the m terms, we get 15m plus -4m is equal to 11m. It's like 15 take 4. And 12 plus 10 equals 22. So that's the value on the right. So now we solve it like we've done many times before with equations. What we do is we divide both sides by 11 to get m equals 2. What we then do is substitute that back into one of the first two equations. Doesn't matter which one, so we'll choose the first one. We replace the m in the first equation with a 2. So we go 2k plus 5 times 2 equals 4, and we simplify that to this stage. We now look to get k by itself by removing the 10 and then the 2. You remove the 10 by subtracting and then divide by 2. And if we go through and solve that, we end up getting k equals -3 for the other unknown value. So the solution to the simultaneous equations is that m equals 2 and k is equal to -3. And we can check to see it's correct by substituting those values back into both equations to see that they both work.